Hello everyone, my name is Sinenhlanhla Sikhosana, a SARAO postdoctoral fellow based at UKZN. Today I'll be telling you about my research, which is searching for diffuse stereo emission in galaxy clusters. So what are galaxy clusters? Well, individual galaxies like our Milky Way don't like isolated environments and often exist in a group of about 1,000 bound together by gravity, and this is what we call galaxy clusters. These are the largest gravitationally bound objects in the universe. Galaxy clusters can be observed at multiple wavelengths such as optical, X-ray, and radio, and different wavelengths show you different parts of the galaxy clusters. So the optical wavelength often shows you the individual galaxies, while the radio and X-ray tell you about the intracluster medium, which is basically a gas between the individual galaxies. The intracluster medium consists of particles such as protons, electrons, and also magnetic fields. Because you have magnetic fields and sometimes highly energetic electrons, you see what we call the synchrotron emission, which is basically electrons spiraling around magnetic field lines and producing photons. So the ejected photons are actually observed at radio wavelength, and it is what we observe as diffuse emission. So diffuse emission exists in different types, such as the giant radio halos, which is the largest of them, of megaparsec scale and centrally located in galaxies. We also have what we call the radio relics, which are more on the outer skirts of the galaxy clusters and are also very large in size. Smaller in size, you have what we call the mini halo, which is very similar to the giant radio halo, however smaller in size, but it's also centrally located. Finally, you have what we call the revived fossil plasma, which is much smaller in scale, the smallest of them, and they exist in forms of radio phoenixes and gently re-energized tails. And so these radio sources are actually observed using interferometers, and for my projects I've used instruments such as the Giant Meter Wave Radio Telescope, which is based in Pune in India, and the Meerkat Telescope, which is based in the Northern Cape in South Africa, and the Very Large Array, which is based in SARAO in the United States. And basically we use these interferometers to detect the diffuse emission and then create images which we use to analyze the different diffuse radio sources. However, these are not the only instruments we use. So we use the Atacama Cosmology Telescope, which is at microwave wavelength, and in Chile. And basically what we use this instrument for is to detect the galaxy clusters. We also use X-ray telescopes such as Chandra and XMM Newton, and the optical telescope, which is the Southern African largest telescope, which is also based in the Northern Cape. And basically what we use the multi-wavelength telescopes for is to follow up the interesting objects that we find within galaxy clusters. And this is because theories say that these objects form when two of these very large objects, galaxy clusters, collide. And now this collision produces enormous amount of energies. And this energy is then injected to the intracluster medium, the gas, and as a result, exciting and energizing the electrons, which then results in the diffuse emission. And so having a multi-wavelength view of this object actually tells us a lot on how the diffuse emission is related to the merger activity within galaxy clusters. So why do we actually conduct this research? Well, these are some of the questions that we are trying to answer, and it is basically where do these relativistic electrons actually come from, and how they're actually transported to such large scales. And also we want to understand how this emission actually evolves over large scales of time, and how it looks like on the different masses of the galaxy clusters. And in essence, while answering these questions, we also get to understand how the large-scale structure in the universe, such as galaxy clusters, evolve. Thank you for attending my virtual talk.